Hi guys, in this video we're doing a factorial theorems. So first of all, we're going to prove this theorem here. So to prove these theorems, you have to know the identities of the factorials, theorems, and then also the definition of factorial theorems. So now let's consider the definition. So definition of this. So if you have n, choose k. That's it's equals to n factorial divided by k factorial multiplied by n minus k factorial. That's a definition. It's the first definition of n choose k. So that's the definition, one of the definitions of the factorials. So the next one is identities, because in order to prove this theorem here, you have to know the identities and then also the definitions. So the identities. So the first identity is 1 plus n plus 1 factorial is equals to n plus 1 multiplied by n factorial. That's the first identity. So this identity, more practical example, is like if n factorial, which is a 5 factorial, is the same as 4 plus 1, which is 5, and then 4 factorial. So this in more practical example is like you are going to have 5 multiplied by 4 factorial. So 4 factorial, you know that 4 factorial is 4 times 3 times 2 times 1. That's 4 factorial. So this is the same as 5 factorial, because if you can substitute this 4 here with that, you are going to get 5 factorial. So this is the first identity. So the second identity is it's n minus 1. So if you have n minus 1 factorial is equals to n minus 1 multiplied by n minus 2 factorial. So it's like if you have a 4 again, let's say n is 4, then n minus 1 is like a 3 factorial. So this is equals to n minus 1, which is 4, minus 1, then n minus 1, which is 4, n minus 2, which is 4 minus 2 factorial. So this is 3 factorial, which is the same as here you are going to get 3 multiplied by 2 factorial. So 3 multiplied by 2 factorial is like 3 times 2 times 1. So which is the same as 3 factorial. So that's a second identity. And then the last identity that we are going to consider is this one. Actually, this is a part of a definition of factorial, because it's n factorial is equals to, in more practical example, it's n factorial, it's n multiplied by n minus 1 factorial. So it's n factorial is equals to n open bracket n minus 1 factorial. So we are going to use these identities and then definition to prove that theorem. So now let's go to the theorem. Then you have n choose k plus n choose k minus 1. You have to prove that this is equals to n plus 1 choose k. So we are going to start with a left hand side. Let's say left hand side. We are considering left hand side. We want to prove that what's on the left is equals to what's on right. So n choose k, as we are using this definition here, we're going to use that definition, is going to be the same as n factorial divided by k factorial open bracket n minus k factorial. So that's the first thing that we know. So for the second one is n choose k minus 1. So we're going to say plus the second one is n factorial divided by k minus 1 factorial multiplied by, remember that I take this as my k here, I take that as my k, and then it's going to be if we do that, it's going to be n n minus open bracket k minus 1. So these two things are the same. Remember that here I take n minus k minus 1, remember, because n choose k minus 1, doesn't choose k, so it's n minus k minus 1. So after that it's equals to, you can take n as the common factor out, and then you're going to have n factorial out. You are left with inside, it's going to be 1 all over k factorial n minus k factorial plus 1 all divided by k minus 1 factorial open bracket n minus k plus 1 factorial. Then after that you are going to multiply this by that, to find the lowest common denominator. Yeah, so this is what we have on our left hand side. So I'm going to solve it here. So we have n factorial, then open bracket, we're going to take this one multiply by 1, which is going to be k minus 1 factorial n minus k plus 1 factorial, and then you take that, you multiply by 1, you're going to get plus k factorial open bracket n minus k factorial, all of this divided by this multiply by that, which is going to be k factorial open bracket n minus k factorial multiply by k minus 1 factorial multiply by n minus k plus 1 factorial, the last one. Then after that you are going to apply the identities. So here what I see is like you see this one here, you see k minus 1 here, and then here you see k. So k minus 1 and then k, they have a common identity. So since they have a common identity, we are going to change k to k minus 1, because remember that n factorial is equals to n multiplied by n minus 1 factorial. So if we can change this, what is this, k minus 1, oh, this k to k minus 1, then we can have a common factor, like k factorial is the same as k open bracket k minus 1 factorial. So therefore the next step is n factorial open bracket, then I will have k minus 1 factorial, then open bracket, and then inside of this bracket I will have n minus k plus 1 factorial. Remember that I'm replacing this k with this here, so it's going to be plus. Remember that if I take k minus 1 as a common factor here, this is equals to that, so it's going to be k is going to be, k minus 1 is going to leave, then you close the bracket. So remember that here you have a k minus 1, so k minus 1 inside of this, take a look of these brackets here, you have this bracket here and then that bracket there, and then these two brackets are not the same, you have this bracket and then that bracket. So that therefore that means k minus 1 factorial is a common factor between this and then that, which we changed k factorial to that identity, and then the whole of this still divided by k factorial into n minus k factorial, k minus 1 factorial, and then n minus k plus 1 factorial. Therefore this k minus 1 is going to cancel the k minus 1 factorial. So after cancelling that out, the next step is going to be the last step is n factorial. We still have that n factorial, open bracket. Here we're left with this, so we can change this one here to another identity because we had identity as this one. So here is like you have a n plus 1 because you have a n minus k, so plus 1. So we are going to classify this n minus k as n. So if we classify that as n, therefore we know that n plus 1 factorial is the same as n plus 1 then multiply by n factorial. So here it's like if you have a, therefore if you have a k n minus k plus 1 factorial is the same as n minus k plus 1 multiplied by n minus k factorial, because we are classifying this as a n. So therefore you are going to have something like that. Then here, therefore you are going to have a common factor, but let me write it here so you can see. You are left with here, remember that you are left with n minus k. We're changing this n minus k to that thing, so it's n minus k plus 1 multiplied by n minus k factorial, then plus k n minus k factorial, all divided by k factorial into n minus k factorial, then multiply by n minus k plus 1 factorial. So here you have a common factor. You have your common factor as a k minus n minus k and then n minus k factorial. So if you take out that common factor, this common factor now is going to cancel up this. So these two things are going to cancel this denominator here. So the next step is going to be, so now we have n factorial, open bracket, what's left inside the bracket, it's n minus k plus 1 and then plus k all divided by k factorial and then multiply by n minus k plus 1 factorial. So that's what's left inside the bracket. Then here you have a k which is going to cancel out the k. So you are going to left with n factorial multiplied by n plus 1 all divided by k factorial into n minus k plus 1 factorial. So you can relate this to something else, because at the beginning, as I told you, that we are going to consider the definition and then the identities. This is one of the definition. This is the one above there, n factorial multiplied by n plus 1 is the same as n plus 1 factorial, because n plus 1 factorial, I told you that this is the same as n plus 1 multiplied by n factorial. So we can replace the numerator there by n plus 1 factorial. So we are going to do that now. So let's replace the numerator with n plus 1 factorial. So that means the numerator now is going to be n plus 1 factorial divided by k factorial, open bracket, n minus k plus 1 factorial. So again, you can relate this to something else, because you know that n factorial, not n factorial, n choose k is the same as n factorial divided by k factorial multiplied by n minus k factorial. So here our n is like it's n plus 1. So our n is n plus 1. So we are going to do the very same procedure here to go back. Like now we're here, and then we have to take this back to the original. Then therefore to take this to the back, it's going to be n. Our n is n plus 1 in this case, because n is this one, is the one there. So it's n plus 1. Then choose, we are going to look at this. Therefore choose k. K is the same here, still k. So choose k, therefore you will have k here. Then this left hand side now is equals to the right hand side. If you can go back and look at this, because they said to have to prove that this is equals to that. So we proved that. Then we're done. See you next time.